So dual nature of radiation, interference, diffraction, polarization, supports wave nature of light, wave nature of radiation. On the other hand, photoelectric effect Compton scattering, black body radiation, these all are supports particle nature.
Photoelectric effect and then
Compton scattering. Compton scattering টা তোমাদের সিলেবাসে নেই, but it is another effect which supports particle nature of light. Just a minute. এবার অনেকটা বেশি খাতা দেখা যাবে, দেখা পরিষ্কার দেখা যাচ্ছে?
খাতাটা কিন্তু একটু ছোট দেখা যাচ্ছে, একটু বেশি দূর হয়ে যাচ্ছে।
বেশি দূর হয়ে যাচ্ছে? তুমি কি মোবাইলে করছো?
হ্যাঁ, মোবাইলেই করি।
আচ্ছা আচ্ছা, মোবাইলে করলে অসুবিধা হবে।
ল্যাপটপে করার সৌভাগ্যটা এবার হয়নি।
ল্যাপটপ ডেস্কটপ যেকোনো একটা থাকলে সুবিধা হয়, কম্পিউটার থাকলে সুবিধা হয়।
ল্যাপটপটা থাকলে সত্যি একটা সুবিধাটা হয়, কিন্তু কি করা যায়, স্যার সৌভাগ্য নেই।
সেসব বিষয় নয়, অনেক কিছু থাকলে অনেক সুবিধা হয়, সবকিছু সবার থাকে না।
ল্যাপটপে জিনিস একটু বড় দেখায়।
হ্যাঁ, আর কিছু তোমরা ল্যাপটপ কেন, ডেস্কটপ থাকলেও ঠিক আছে, অসুবিধা নেই।
মানে ল্যাপটপ বা ডেস্কটপ টাইপের জিনিস ওরকম কিছু, দুটোই তো প্রায় এক, আলাদা কি?
ডেস্কটপ অনেক বেটার, ডেস্কটপ রাখার জায়গা লাগে আলাদা করে, সেটা ছাড়া ডেস্কটপ বেটার।
ওটা একটা প্রবলেম ডেস্কটপে, যে আলাদা করে ফুল সেটআপ লাগে। বাট সেই হিসাবে আপনার ল্যাপটপ অনেকটা বেশি কস্টলি দেখতে গেলে।
নট রিয়েলি, মোটামুটি এখন কস্টিং একই চলে এসেছে।
কত হয় তা আপনার একটা ডেস্কটপ? 30,000 35,000 হয় খুব বেশি হলে। মানে একটা নর্মাল যদি কিনতে হয়, আর এখানে যদি আপনার একটু ভালো কিনতে হয় তাহলে তো 40-50,000 এমনি হয়ে যায়।
ল্যাপটপ না না, আমার এই যে ল্যাপটপটা 30,000 টাকা, Core i3।
হ্যাঁ, Core i3। আপনার ডেস্কটপ ওখানে শুরু হয় i3 তে ডেস্কটপ। ডুয়াল কোর প্রসেসর ওদের হয়ই না। আমার একটা ল্যাপটপ আছে, ওটা একটু ডিউজ।
ওকে, লিভ দ্যাট। তাহলে তোমার কিছু এক্সপেরিমেন্ট থাকছে, যেমন ইন্টারফারেন্স, ডিফ্রাকশন, পোলারাইজেশন, তারা হচ্ছে ওয়েভ নেচার অফ লাইট কে সাপোর্ট করছে। whereas photoelectric effect, Compton scattering, black body radiation, they supports particle nature of light. ঠিক আছে? So by assuming this shows that light radiation has dual nature. So this shows light radiation has dual nature. So sometimes it behaves like wave, and sometimes it behaves like particle. Okay. So basically it depends on the probe, how you are probing. Depending on that, it may show the particle nature or wave nature. How you are probing, depending upon that, it may show the particle nature or the wave nature. Okay.
Yes, sir.
Now, like dual nature of radiation, there is also dual nature of matter. In 1924 একজন ফ্রেঞ্চ ফিজিসিস্ট
সেটা তুলবেন?
বেসিক্যালি উনি ফিজিসিস্ট ছিলেন না, উনি হিস্টোরিয়ান ছিলেন। হিস্ট্রি অফ সায়েন্স নিয়ে কাজ করতে গিয়ে ওনার মনে হয় আইনস্টাইন এবং আইনস্টাইনের এনার্জি, মাস এনার্জি রিলেশনশিপ এবং নেচারের সিমেট্রি প্রপার্টি, এই দুটোকে মিলিয়ে ওনার মনে হয় যে যেমন রেডিয়েশনের ডুয়াল নেচার আছে, সেরকম ম্যাটারেরও ডুয়াল নেচার থাকতে হবে। ফ্রেঞ্চ ফিজিসিস্ট লুইস ভিক্টর দ্য ব্রয়। এটা দেখলে মনে হবে ডি ব্রগলি, বাট ইট প্রোনাউন্সড অ্যাজ দ্য ব্রয়। The Broglie. He put forward a bold hypothesis that material particles in motion should display wave-like properties. His reasoning was based on the following two consideration. His reasoning was based on two considerations. What are they? First, two physical quantity govern all forms of physical universe are mass and energy. Two physical quantity two physical quantities governs all the forms of the physical universe. are mass and energy. Now, this mass and energy are interlinked by Einstein-Mass energy relationship. Mass and energy are interlinked by Einstein's energy equivalence is equals to mc square. So this shows there is a complete equivalence between matter and radiation. This shows there is a complete equivalence between matter, that means mass, and radiation, that means energy. So there must be a natural symmetry between matter and radiation. Second consideration is very important. Nature loves symmetry. Now, since radiation has dual nature, therefore, from symmetrical consideration, from symmetric consideration, the Brave predicts that matter must also possess dual nature. ম্যাটারেরও তাহলে ডুয়াল নেচার থাকতে হবে, রেডিয়েশনের যেমন ডুয়াল নেচার আছে, ম্যাটারেরও তাহলে ডুয়াল নেচার আছে. It should not only behave like mass points, but they should also exhibit wave nature in motion. Okay, তাহলে the wave associated with material particles in motions are called matter wave or the Brave waves, and their wavelengths are called the Brave wavelengths. The wave associated with material particle in motion are called matter wave, Just a minute. Are called matter wave or the Broglie wave. And the wavelength and their wavelength is called the Broglie wavelength. Now let us find the Broglie wave equation. Now considering photon as an EM wave, frequency nu, its energy from Planck's formula, Planck's quantum theory, is given by E is equals to h nu from Einstein mass energy equivalence. We can write E is equals to mc square. Hence, this h nu is equals to mc square or hc by lambda is equals to mc square or lambda equals to h by mc is equals to h by p, where p equals to mc is a momentum of photon and lambda is the wavelength of the radiation. Yes, p is equals to mc is the momentum of the photon and lambda is the wavelength of radiation. Now this equation has been derived for a photon of radiation. Now according to the Broglie's hypothesis, it must be true for material particles. This h equals to, lambda equals to h by p. This is derived for a photon of radiation. Now, according to the Broglie, this is also true for a photon or for a material particles like electron, proton, neutron, etc. in motion. We will show that static, no wave is associated with static particle. We will show that also. If m is the mass of a particle, v is the velocity of the particle, then wavelength lambda associated, sorry, with that particle is lambda equals to h by p is equals to h by mv. This is called the Breuer's wave equation. For material particle. Now lambda is property wave equation. Of wave, and momentum is property of particle. So this equation lambda equals to h by p gives you interrelation between the wave character and the particle character. Wave character and the particle character. Okay. Now, from this equation, we find that lambda is inversely proportional to the momentum. Lambda is inversely proportional to the momentum. And also, if v equals to 0, lambda equals to h by mv is infinity. So this implies that waves are associated with material particles only when they are in motion. Waves are associated with material particles only when they are in motion. So only when the particles are in motion, the wave are associated with material particles. If the particle is in static condition, the wavelength associated is infinity. That means basically no wave is associated with the particle. Is it okay?
Yes, sir.
Now, to associate it with the Breuer wave, just a minute. Thirdly, to be associated with W wave, a particle need not to have a charge. No charge required to be associated with the Broglie wave. So they are that is why the Broglie waves are also called matter waves. And that is why we can say that W wave cannot be electromagnetic in nature. EM in nature. Why? Because EM wave are only associated with accelerated charge particles. But the Broglie wave is associated with all kinds of particles, whether charged or uncharged, no matter. We can also calculate the Broglie wavelength of an electron, and it is detected. Electron wave has been detected already by using a diffraction type experiment done by Deviation and Jarma. Let us first calculate the Broglie wavelength of an electron. Let us consider an electron of mass m. Charge E. Let V is final velocity. Attained by the electron when it is accelerated from rest. Through a potential difference V volt. Now the kinetic energy gained by the electron should equals to the work done on the electron by the electric field. Now the kinetic energy gain K is equals to half mv square, which is equals to p square by twice m. Now work done on electron E into V. So this P square by twice M equals to EV, or P is equals to root over of twice MEV.
সেটা p squared by কি লিখেছেন?
P square by twice M. কাইনেটিক এনার্জিটাকে হাফ mv স্কয়ার লেখা যায়। আবার পি স্কয়ার মানে কি m স্কয়ার v স্কয়ার।
হ্যাঁ,
তাহলে আমি যদি উপরে পি স্কয়ার লিখি, উপরে লিখলাম m স্কয়ার v স্কয়ার, নিচে m দিয়ে দিলাম পি স্কয়ার বাই টুয়াইস m। তাহলে মোমেন্টামটা হলো এটা, হয়েছে লেখা?
হ্যাঁ,
মোমেন্টাম এটা যখন পেয়ে গেলাম, তখন W ওয়েভলেন্থ lambda equals to h by p, h by root over twice mk, or h by root over twice mev. Now we will use the value. H is equals to 6.63 into 10 to the power minus 34 joule second. M is equals to 9.1 into 10 to the power minus 31 kg. E is equals to 1.6 into 10 to the power minus 19 coulomb. If we use this value, then lambda is equals to 6.63 into 10 to the power minus 34 by root over 2 into 9.1 into 10 to the power minus 31 into 1.6 into 10 to the power minus 19 into V. If you do the calculations, you will got 12.3 into 10 to the power minus 10 by root V meter, or 12.3 by root V angstrom. Okay.
হ্যাঁ স্যার।
Now, when the accelerating potential V is equals to 120 volt, we find lambda equals to 0.112 nanometer. So this wavelength is of the same order as the spacing between the atomic planes, having the same order that as the spacing between the atomic planes in crystal. So this suggests that matter wave associated with electron can be diffracted by, yes, this suggesting that matter wave can be diffracted by atomic planes of a crystal. Now, what is diffraction? Diffraction is some preferential scattering if we find the literal meaning of diffraction, it means bending of light beam around the knife edges or encroachment of light in geometrical shadow region. When the size of the obstacle is compared to the wavelength of the used light, then the shadow is not sharp. There is some encroachment of light in the geometrical shadow region. This is called diffraction. But diffraction can be done using a single slit, a double slit, or a multiple slit. That multiple slit is called grating. Grating is what? We basically use a glass plate and etched equispaced line on that glass plate using a diamond cutter. Now, these lines are behaves like the opaque region, and the region between two lines behaves like a slit. So it behaves like a multiple slit. Now it has been found, it is called diffraction grating. Now it is found diffraction can be possible when the size of the slit is of the order of the wavelength of the used light. Now, so the ordinary diffraction grating cannot be used to for the diffraction of electron or
Grating.
yes, grating, grating, grating. X-ray or electron beam can be diffracted using a crystal, where the crystallographic planes behaves like a grating. Okay. Deviation and Germer detected electron beam using this diffraction experiment and awarded Nobel Prize in 1929. Sorry, and due to this discovery of matter wave in 1929, the Broglie awarded Nobel Prize on physics. Okay. So let us find the experiment of deviation and Germer. Detection of matter wave. In 1927, Deviation and Germer designed an experiment to study the wave property of electron. Designed an experiment. Germer. Deviation and Germer devised an experiment to study the wave property of electrons. That they have used an electron gun as a filament fitted with a low tension battery, LTB. Then we have a perforated anode.
একটু তো
These anode and cathodes are connected with a high tension battery, so that this electron coming out of this electron gun can be accelerated to a very high acceleration, very high energy. Then this accelerated beam was incident on a nickel crystal. This crystal can be rotated about its axis, so that by rotating the crystal we can change the angle of incidence. Everything is put into a vacuum chamber, and this electron beam, after getting scattered from this nickel crystal, is detected with the help of a movable detector. This is basically a Faraday cup which responds the detection of electron, and this is connected with a galvanometer. Whenever one electron is coming, we get a one. This is a movable collector. We get a one peak of current. Now, if this angle is theta,
so এটা কি লিখেছেন এটা 2 গ্যালভানোমিটার
2 galvanometer is connected to a galvanometer. If this theta, this should also theta, and this is the scattering angle phi. So this
ওটা কি মুভেবল
movable collector. Now the emitted electron beam is collimated. Collimated means we made the beam very fine, very narrow beam of electron. We get this very narrow beam of electron when it's passed through this perforated anode, and this electron beam is directed against the face of a nickel crystal. The crystal is capable of rotation about an axis perpendicular to the plane of the paper. The electrons scattered in different direction by this nickel crystal, are received by a movable detector, which is just an electron collector. Thus, we measure scattered electron intensity as a function of scattering angle. We measure the intensity of scattered electrons as a function of scattering angle. As a function of scattering angle. The angle between the incident and the scattered electron beam. Scattering angle means the angle between the incident and scattered beam. That is called scattering angle. This experiment is repeated for different accelerating potential. The experiment was repeated for different accelerating potential. Let's have a plot of the experimental data. It is plotted in a polar graph where this vertical line represents the direction of incidence wave and this vertical line gives the direction of incident electron, and this gives the wave vector, the position vector at any point, gives the intensity at that point as a function of scattering angle. So this is at 44 volt. You can see there is a preferential direction in which you are getting greater intensity. There is a preferential direction in which you are getting greater intensity than the other directions. This is a sign of diffraction. Now, if we increase the accelerating potential to 48 volt, this preferential scattering is more prominent. This preferential scattering is more prominent. Now, when we increase the accelerating potential to 54 volt, we are getting the maximum intensity at a scattering angle of 50 degree. When we increase the accelerating potential to 54 volt, then we got a maximum preferential scattering at a scattering angle of 50 degree. On further increase of accelerating potential to 64 volt, there is a decrease of this peak intensity. If we go up to 68 volt, then the peak is disappears. So from this diffraction data, that preferential scattering, you can see that preferential scattering is happening. So that means some diffraction is happening. Now from the figure, the glancing angle theta is measured by theta plus phi plus theta is 180 degree, where theta is glancing angle. So 2 theta is equals to 180 degree minus phi, or theta equals to 90 degree minus phi by 2. So when you know theta, that means you know phi. If you know phi, that means you know theta. Now, for phi equals to 50 degree, theta equals to 90 minus 25. That means 65 degree. For the interatomic spacing for nickel crystal, হয়েছে?
হ্যাঁ।
So the interatomic spacing for nickel crystal D is equals to 0.914 angstrom. Now, for first order diffraction maxima, now for diffraction maxima, we have the Borg's law.
স্পেলিংটা
BRAGG, Borg's law for diffraction maxima of nth order, which gives you 2D sine theta is equals to n lambda, where n is the order of diffraction. Now, for first order diffraction maxima, so here you are getting the direction at which you will get the diffraction maxima. Okay, and that depends on the wavelength and the order of diffraction. Okay, so it is 2D sine theta equals to lambda. So we can use the value of d and theta to calculate lambda. So 2 into 0.914 into sine 65 degree, that's much angstrom. It will come out 1.65 angstrom. So from diffraction experiment, using Borg's law, you are getting the wavelength of the electron beam is 61.65 angstrom. 1.65 angstrom. Now we will use the Dabrois formula to calculate the wavelength of calculate the Dabrois wavelength of electron beam, of that electron beam. Dabrois hypothesis. The wavelength associated with an electron beam accelerated through (54 volt), lambda equals to 12.3 by √54 angstrom, and it will come out as 1.66 angstrom. So the experimentally measured wavelength is very close to that of estimated from the Dabrois hypothesis. Experimentally,
একটু তুলবেন স্যার কপিটা?
obviously, measured wavelength is very close to that of estimated from the Dabrois hypothesis. So this proves the existence of the Dabrois wave. Okay.
Yes.
There is another experiment devised by G.P. Thomson. Here also we use an electron gun for getting an accelerated electron beam. Then they are passed through a thin foil, which acts as a diffraction grating. And when we get a result on a photographic plate, we see alternative bright and dark circle as obtained by diffraction experiment. So this is a diffraction rings. This is G.P. Thomson's experiment.
There are thin foil.
Thin foil. This is electron wave. This experiment was devised in 1928. From an electron gun, a beam of electron accelerated through a potential difference of 10 to 54 kilovolt incident on a thin platinum foil. The emergent beam is received on a photographic plate. The electron beam is diffracted at the spacing between the randomly oriented crystals of the thin foil. On the photographic plate, we get a circular diffraction pattern similar to that of Lewis X-ray diffraction pattern. Okay. Circular diffraction pattern obtained on the photographic plates similar to Lewis X-ray diffraction pattern. Lewis X-ray diffraction pattern. So thus conclusively proves that the electron beam behaves like the wave. Conclusively proves that electron beam behaves like a wave. Okay. Now, when electron beam is behaving like a wave, and we can control the wavelength of the electron beam, then we can use this electron beam to get a microscope, to prepare a microscope having very large magnification power. That microscope is called electron microscope. It is an important application of the Abreu's wave design to study very minute objects like virus, microbes, and crystal structure of solids. And it was designed by Ernest Ruska in 1930. What we know, the magnification power of a microscope is proportional to 1 by lambda. So with an optical microscope, magnification of the order of 15 ratio is possible. So up to 1500 magnification power is possible with optical microscope. So this limit is due to the large wavelength of visible radiation. This limit is due to the large wavelength of visible radiation. By selecting now, when a electron beam is accelerated with a potential difference of V volt, then lambda comes 12.3 by root over V angstrom. Now increasing V, we can decrease lambda of electron beam to our desired value. And that is why an electron microscope have a magnification as high as 1 lakh. Sorry, 10 lakhs. Now you can say, sir, X-ray and gamma ray also have very small wavelength, but they are very hard to detect and focus. Electron beam can be focused using electric and magnetic fields. Very efficiently using electric and magnetic fields known as electromagnetic লেন্স। আমরা যেরকম অপটিক্যাল ভিজিবল লাইট কে অপটিক্যাল লেন্স দিয়ে হচ্ছে যেমন ভিজিবল লাইট কে আমরা অপটিক্যাল লেন্স দিয়ে ফোকাস করতে পারি, সেরকম ইলেকট্রন বিম কে আমরা ইলেকট্রোম্যাগনেটিক লেন্স দিয়ে ফোকাস করতে পারি। ঠিক আছে। So by using this electron microscope, electron beam as the illuminating agent in a microscope, we can prepare an electron microscope which can have magnification as high as 10 lakh. With this chapter is finished. Let's have one or two quick problem. Then we will move to the next chapter. I have seen two problems. Do them.
স্যার প্রথমের অ্যান্সার 1.23 অংশ।
হ্যাঁ বলো। প্রথমের আনসার
1.23 অংশম।
1.23 angstrom। হ্যাঁ ঠিক আছে।
So 28 টা একটু হিল দেওয়া হয়েছে।
দিচ্ছি। 28 টা কি বলেছে? A particle moving 3 times. হ্যাঁ বলো।
এবার বলুন ডিসকানেক্ট হয়ে গেছে।
বলেছে particle moving 3 times as fast as an electron. The ratio of their wavelength দেওয়া আছে। Of the particle to that of the electron is there. Calculate the particle's mass. তাহলে তোমার ওয়েভলেন্থ কি? h by p, h by mv,
হ্যাঁ হ্যাঁ হ্যাঁ, h by
lambda is equals to h by mv। এবার তুমি ল্যামডা পি আর ল্যামডা ইলেকট্রন বার করে নাও। ল্যামডা পার্টিকেল h by mp vp, আর ল্যামডা পার্টিকেল ল্যামডা ইলেকট্রন হচ্ছে h by me ve। তারপর তাদের রেশিও নাও, ওয়েভলেন্থের রেশিও দিয়ে দিয়েছে। ভেলোসিটি গুলো রেশিও দেওয়া আছে, তাহলে তুমি সহজেই মাসটা বার করতে পারবে,
হ্যাঁ হ্যাঁ।
মাস অফ দ্য ইলেকট্রন ইউজ করে।
কিন্তু আমি তো পার্টিকেলের ভেলোসিটিটা জানি না।
কেন দেওয়া আছে? যে দেখো ইলেকট্রন আর পার্টিকেলের ভেলোসিটি রেশিও দেওয়া আছে, পড়ো অঙ্কটা।
আচ্ছা,
কি দেওয়া আছে প্রথমে, কি বলা আছে?
এখানে তো পার্টিকেল আর এর ওয়েভলেন্থের রেশিওটা আছে।
ওয়েভলেন্থ না, ইয়ের রেশিও আছে, ওয়েভলেন্থের রেশিও আছে, ভেলোসিটির রেশিও আছে। আরে
কোথায়?
প্রথমেই তো বলেছে দ্য পার্টিকেল ইজ মুভিং 3 টাইমস ফাস্ট
আচ্ছা আচ্ছা
অ্যাজ অ্যান ইলেকট্রন। তাহলে সেটা কি?
1 3 স্যার 5.505 into 10⁻⁻27।
ঠিক করে করো। 5 পয়েন্ট
হ্যাঁ 5ই তো আছে।
ঠিক করে ক্যালকুলেশন চেক করো।
তাই তো আসছে স্যার ক্যালকুলেটর উপরে।
তাহলে
মানে
ইয়ে
অ্যান্সার
চেক
কত?
করো, ভুল করছো, ভুল ভুল হয়েছে, অনেক অনেক চেঞ্জ। আনসার আছে 1 পয়েন্ট, mass of the particle is 1.675 into 10 to the power minus 27 kg. দেখো ল্যামডা পি পাই ল্যামডা ই দেওয়া আছে, ভিপি ইজ ইকুয়াল টু 3 ভিই দেওয়া আছে। ল্যামডা পি বাই ল্যামডা ই হবে এম ই ভিই বাই এমপি ভিপি। তাহলে এমপি এমই এমপি বাই এমই is equals to VE lambda E by VP lambda P. তাহলে VE by VP into lambda E by lambda P। এবার দেওয়া আছে হচ্ছে VP is equals to thrice VE, তাহলে VE by VP is equals to 1/3, আর lambda P by lambda E is দেওয়া আছে 1.813 into 10 to the power minus 4। তাহলে ল্যামডা ই বাই ল্যামডা পি 1 by 1.813 into 10 to the power minus 4। তাহলে এমপি is equals to এমই into lambda e by lambda p into ve
এটা তো
by vp। 9.1 into 10 to the power minus 31 into এখানে দাঁড়াচ্ছে 1 by 3 into 1.813 into 10 to the power minus 4। দেখো কত হচ্ছে।
0.3735।
কি উল্টো পাল্টা বকছে, ক্যালকুলেশন করতে গিয়ে এত গন্ডগোল করছো কেন?
সরি 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 সরি, এটা 1 পয়েন্ট ছিল না, 1.6749
হ্যাঁ, into 10 to the power
-27।
বোঝা গেছে?
স্যার পুরোটা একবার দেখ। হ্যাঁ স্যার পুরোটা একবার দেখ। পুরো অঙ্কটা টুকু একবার দেখা।
হ্যাঁ,
একটু তুলবেন?
Just a minute. Our next chapter is atoms. After the discovery of two types of charged particle, protons and electrons, positive and negatively charged particle, J.J. Thomson was the first to predict the atomic model. In 1898, J.J. Thomson proposed that an atom is a sphere of positively charged matter. Atom is a sphere of positively charged matter with electrons which are negatively charged embedded in it. With electrons which are negatively charged embedded in it in such a way in such a way that total positive charge equals the total negative charge. In such a way that the total positive charge is equals to the total negative charge. So as a whole, the atom remains electrically neutral. The positive charge is uniformly distributed over the entire atom, and the arrangement of electrons inside the continuous positive charge is similar to the seeds of a watermelon or the palms of pudding. The positive charge is uniformly distributed positive charge is uniformly distributed over the entire atom, positive charge is uniformly distributed over the entire atom. The arrangement of electrons inside the continuous positive charge is similar to the seeds of watermelon or palms in a pudding. That is why it is also called palm pudding model. Cake cherry model. So the electrons are arranged in such a manner that their mutual repulsion is balanced by their attraction with the positively charged matter. The electrons are arranged in such a manner that their mutual repulsion is balanced by the attraction with the positive charge. So something like this. If you consider this is the atom, the whole atom is positively charged matter. And the electrons are embedded in it, like seeds of watermelon or palms in a pudding. This is Jesse Thomson's proposition. Now, Thomson's model was able to explain some success the process of chemical reaction and radioactive disintegration. Chemical reaction এবং radioactive disintegration কে কিছুটা হলেও এক্সপ্লেন করতে পারে model was able to explain with some success the processes like chemical reaction and radioactive disintegration. Now, to explain the observed spectra of elements, to explain the observed spectra of elements from some assume assume that slight perturbation means slight disturbance of the system from its equilibrium position. That slight perturbation, PERTURBTION, slight perturbation of atoms causes vibrations of electrons about their mean position. Their equilibrium position. So these vibrating electrons, emits electromagnetic radiations of their own frequency of oscillation. Now, why this model failed? It's remained popular till 1991 and was discarded later on due to the following drawbacks. First one, it could not explain the origin of several spectral series in case of hydrogen and other atoms. And secondly, হ্যাঁ,
এই স্পেকট্রাল লিখেছেন তারপর
it could not explain the origin of several spectral series ACRIES of hydrogen and other atoms, and secondly, it failed to explain the large angle scattering. It failed to explain the large angle scattering of alpha particle in Rutherford's experiment. Rutherford's alpha particle scattering experiment. We will discuss this portion in the next class. Rutherford's alpha particle scattering experiment. Then Rutherford gives an atomic model. What are the limitations of that model? Then Bohr's has come into play, and Bohr's given the atomic model, which is Niels Bohr. Niels Bohr. So this part,
alpha scattering was there was no success in the alpha scattering. It was totally a failure.
no. Alpha particle scattering experiment is not failure.
No. It was not failure. He was unable to explain the that his atom is stable.
Yeah, stability of atom, and also the line spectra cannot be explained on the basis of Rutherford's model. That's different
The
story.
series, Baum series and the Lyman series.
Yeah, there's Balmer series, Levin series, Paschen series, Brackett series, Kuhn series. There are 5 series of hydrogen, and also actually line spectra cannot be explained on the basis of Rutherford model. According to Rutherford's model, the spectra should be continuous, but actually we got some line spectra. That means discrete spectra. Okay.
But he was able to explain that there was some positively charged particles also.
That basic proposition was taken by Niels Bohr also, that the nuclear centric atomic structure, that the whole mass, the whole positive charge and nearly the whole mass of the system will be concentrated at a very small region called nucleus, and the electrons will be revolving different orbit around the nucleus. That has been taken from Rutherford's idea. Okay. Then Niels Bohr has used some postulates to restrict the motion of the electrons, and later on quantum mechanics supports
that when the electrons revolve around the nucleus of the positively charged, they continuously radiate radiate some energy, and that's why Maxwell's theory told that how can your atom be stable? It will collide with the and Niels Bohr told that until they go from one shell to the another, either upper or lower,
this restriction of stability orbit, stable orbit, stationary orbit, that when they are in a allowed orbit, the electrons will not emit any energy. This is directly contradiction with the classical electromagnetic theory, and basically this is the first step towards quantum mechanics.
Yes.
Okay. So we will discuss it in the next class. Thank you.
Thanks. Bye, sir.
Bye.